Okay. Well, I just recorded this whole thing and realized that I did not turn on the microphone. It's okay, it's just gonna make this second time so much better. Okay. So what we're doing today is acid-base disorders. We learned this in pharm, but this is just a general acid base and how they work. There is no like medications involved that he put on the slides. So we're just gonna go over how they work real quick. I'll try to wrap it up quick and try to get through the examples more slow, so because that's the big part of it. So we're just gonna start off with some basics to understand. Key values are going to be from blood gases, which give us pH and CO2. And then serum chemistries, which can give us sodium, chloride, and bicarbonate. I think blood gases can also give us bicarbonate, but that's what it said on the slide. So arterial blood gas is what ABG stands for. This is going to give us a set of lab values, and they're going to be lined up like this. They're going to be lined up with pH, carbon dioxide, oxygen, bicarbonate, and BE. I don't ask me what BE stands for. I couldn't figure it out. I didn't look it up, granted, but I just didn't know what it was. But there's only going to be 3 values you really care about from these. It's going to be pH, PaCO2, which is just carbon dioxide, and then HCO3, which is bicarbonate. Okay, so the values you really care about with the normals are going to be pH, which is going to be 7.35 to 7.45, carbon dioxide of 35 to 45, and HCO3, which is 22 to 26. Now, a nice way to remember these is for pH and CO2, well, they both have 35 and 45 in them. You just take off the 7s. And then later on, we'll learn that sodium also falls within a range of 135 to 145. So they all have that like that 35-45 going on, except for bicarb. So it's kind of easy to memorize those real quick, if you needed an easy way to memorize those. For the pants, I'm pretty sure they give us values, so not a big deal. Okay, so what is acid, or what are acids, right? Acids are going to be when our blood is acidemic, which just means acidic blood. Emic is blood and acid, of course. This happens when our pH is low, so lower than 7.35, when our carbon dioxide is high, so above 45, or when bicarbonate is less than 22. So bicarbonate is low. Now, I'll explain this here. I see carbon dioxide as an acid, because I think it does act like an acid in our body. And then I see bicarbonate as a base, because I know it acts as a base in our body. So if you can get that idea of those, like how those two work, one being an acid, one being a base, it gets simpler when you get down to like, oh, this is low, so what does it mean? This is high, so what does that mean? If you can get that down, it becomes simpler. And hopefully, when we go through examples, that'll make more sense. Okay, then what is basic? Basic is also called alkalemic, meaning more basic in the blood, or the blood is basic. Alkalosis, alkalemic, mean base. It's just another word for base. So pH greater than 7.45, so a high pH is basic. CO2 less than 35, so a low CO2 is basic. And bicarbonate more than 26, which is more basic, because you have more base. Sorry, my nose is itchy. Okay, then let's have an understanding of what is PaCO2. There's a lot of letters in that acronym. Well, it just means pressure of CO2 in arterial blood, because that's what we're measuring. It's the best way to measure our acid-base balances is through arterial blood. Well, the good thing to ask yourself is, what is CO2 associated with system-wise? Is it going to be our respiratory system or our metabolic system? Because those are the two systems we look at when we're balancing acid bases. Well, when you think CO2, what do you think of, right? You think of air, you think of us breathing, so you think of our lungs, which is our respiratory system. So CO2 is involved with our respiratory system, and that's one way we deal with acid-based conditions, or controlling acid base in our body. So that's why I associate CO2 with respiratory, but then I also associate CO2 with acid, because it acts like an acid in the body. Okay, then what is HCO3 minus? Well, that's what we call bicarb. Bicarb is a concentration of bicarb in the arterial blood gas. It is actively controlled by the metabolic system. Oh, okay. What part of the metabolic system? Well, I believe it's renal, because we learned in renal that in the kidneys, in the glomerulus, and the tubules, it's actively exchanged for hydrogen in the kidneys, and that's how the kidneys balance our pH, is using that. So that's why bicarb is a part of the metabolic system. So associate bicarb with metabolic. And then also associate bicarb with basic. Bicarb, basic. Oh, and by the way, if you see any of these, I know I should have been highlighting. If you see any of these markings, like exclamation marks, that's stuff I think is important, or I think will help you with your studies to like have like little tips and things to like hone in on. Okay, so we're gonna go over Dr. Lowe's rules. I don't know if these are his rules or if he just got them. You know, if he saw someone using them, it's like, oh, that's a good idea, but they're good rules. Rule 1 is pretty simple. We're just gonna look at the pH, see if it's higher or lower. Then we're gonna look at the other values, which is the carbon dioxide and the bicarb, and we're gonna see how those associate with figuring out our primary process, meaning the first process that's causing the issues in our body. So the pH, let me just go over this real quick. So the principle, I'll go over the principle. The principle here says that the body does not fully compensate for a primary acid disorder. What that means is the initial thing will happen. Maybe we have a problem with our kidneys, so we become acidic, right? We start becoming acidic in our body. When our body realizes that's happening, our body's going to want to compensate by making us more basic, so putting more alkalosis in there in our bloodstream. Well, that won't truthfully ever, like, it will eventually, but when we're looking at the condition, that won't be fully compensated. So you'll see the difference. So it won't line up. If it did, then we wouldn't have an issue, right? The pH would be normal, and the bicarb and the CO2 would be off, but our pH would be normal, so we wouldn't think anything of it. No, it's going to be off. Okay, so that's what it's saying. It's going to be off. It's not going to fully compensate. Sorry, I said that kind of confusing. Let me know if you guys need clarification. Okay, so we have 4 primary disorders. We have respiratory alkalosis, respiratory acidosis, metabolic acidosis, and metabolic alkalosis. And again, sorry for all the colors. I wanted to color coordinate to hopefully help understand a little bit. I don't do it that much later on, so hopefully it's not too bad. So the carbon dioxide, a carbon dioxide less than 35 means that we have low acid, right? So less than 35 means low acid. That's going to tell us it's alkalosis, or more basic, because we have low acid. And then we know that CO2 is involved with the lungs, so it's a respiratory process. So you associate low CO2 with respiratory alkalosis. Not always, but generally is what I'm saying. Because it might be compensatory is what I'm saying. It is that, but not primary all the time. So CO2 greater than 45 is going to be more acid, so that's acidosis, more acid, acidosis, and again, CO2 is respiratory. Okay, bicarb. Low bicarb means low base. Low bicarb means low base. So low bicarb means low base means we're going to be more acidic because we have less base. And then we associated bicarb with kidneys, and then kidneys deal with metabolism, right? So bicarb is a metabolic process. So we're going to call it metabolic acidosis when bicarb is low. When bicarb is high, so more than 26, we're going to call it more, it's going to be more basic. So we're going to call it alkalosis, so metabolic alkalosis. Okay, we're going to speed up just a little bit. Okay, there's more than just primary. We can also have mixed in some cases through compensation. Compensation is very important. Compensation is very important. So this means, like, we're not always going to have just respiratory alkalosis. We're not always going to have metabolic acidosis, right? If we did, then our body would be kind of struggling as soon as we get in these situations, because that means we weren't compensating. Our body wasn't trying to change that issue. So that's what compensation is. It's our body trying to fix that complication. I'll explain this a little bit later as well, but we can have a total of 3 abnormalities, meaning 3 processes, right? So any of these 3, but they have to be 1 respiratory and 2 metabolic. And that's the max. They're not always going to have that, but that's the max they can have. The reason why is because you can't have 2 respiratory. The reason why is because one of them's hyperventilation, one of them's hypoventilation. You can't have both. That doesn't work with how you're breathing, right? Your breathing doesn't work that way. So that's why respiratory is 1, metabolic's 2. I feel like that'd be a good question for him to ask. A key thing to know here is the direction of the pH will tell you which is the primary process, meaning whether CO2 is involved with the primary process or bicarbonate, therefore telling you if it's metabolic or a respiratory primary process. Okay? Because what I want, and we're going to do this in examples, what I want you to realize is pH, whichever pH is, whether it's acidosis or alkalosis, look for whether that's the carbon dioxide or the bicarbonate mimics it, meaning it has the same acid or base or alkalosis associated when you do the questions, and it'll make more sense once we get down to it. Whichever one mimics the pH has the exact same. Oh, I almost erased that. Oh, I did erase that. There it goes. Whichever one has the same value or process, that's going to be your primary abnormality. And it'll make more sense later on. This is just in words. Okay, rule 2. I bet you guys remember the anion gap. Oh, so fun. So the anion gap is essentially the gap between the amount of anions and cations you have. Cations are positive values. And the way you remember that is because cation has a T in it, which looks like a plus sign. So cation. I've also heard people say like cats are a positive, but again, that's kind of more subjective. I like cats, but you know. And then you have anions, which are more negative. So as long as you remember that cations have a T in it, and that's T stands for plus, you can kind of fill in the rest. So it's really that gap between those two. It's the gap between the amount of sodium, and there's more to this, but in general, it's the gap between sodium and then your bases, like chloride and bicarbonate, which you can see up here. Right? We're going to use that formula a lot, so please try memorizing this. I'm almost 100% sure he's going to give it to us. I'm almost 100% sure we have to know this. So please know that. What's our gauge, right? Our gauge is when the difference between cations and anions is more than 12. Why more than 12? Well, there's a couple slides you can go over, and it tells you why it's more than 12. I could explain it if you like. It's not super important that knowing why it's over 12. But if you want me to explain it for your understanding, I totally can. I just won't do it right now because it's going to take a little too long. Just know more than 12 means an anion gap is present. Meaning there's a gap between anions and cations. Okay? So over 12. Remember 12? And remember 12 and remember this formula. Okay? Any value over 12 tells you that you're in a metabolic acidotic state. Any value over 12. Because that tells you actually have more sodium than you have base. Or you have more sodium than you have anions. And sodium's a cation, so it's positive. And I associate cations like sodium with acid. And I associate anions, so negatives, with bases. If you remember back from chemistry, that's generally how it works. So if you have more cations, like sodium, right, and that's what the more than 12 signifies, you have more cations, that means you're going to have more acid, meaning put you in a metabolic acidosis, because you have more cations. Cations are more acidic. So what we call that process is an anion gap metabolic acidosis. Now, if you have a metabolic acidosis and your anion gap is less than 12 or at 12, more likely at 12, that's not an anion gap metabolic acidosis. That's just metabolic acidosis. They can be mutually exclusive. kind of, yeah. Sorry, let me take a quick water break. Okay, one also very important thing to know is with anion gaps, when we reach a value of more than 20, that means we have a lot of acid. That's a lot. So that kind of, more than 20 kind of hones us in that this process is going to be a primary metabolic acidosis. That's important because he highlighted this. That's important because if your anion gap's so big that you have so much acid, there's the only way that's possible is if it was the original process causing the issue, meaning the primary process. A compensatory would not be that high. It just would not be that high. That's why it's a primary process. So anion gap more than 12 is anion gap metabolic acidosis, and anion gap more than 20 sits the primary metabolic acidosis. It's the primary process. And that's what he says in his principle here. In his principle, he says the body does not generate large amounts of anion gap to compensate for a primary disorder. So that's saying, like, for instance, if we had a respiratory alkalosis, if the body wanted to produce a metabolic acidosis to fight that off, to kind of like fight off it, because it'd be high pH versus a low pH, theoretically, right? If it wants to fight that, it wouldn't reach this levels of anion gap. The only time this level of anion gap is reached is if it's a primary process. It's like the first process causing issues. So that's a principle he said, so it's probably good to know. Rule 3. Rule 3 is we're going to be taking that anion gap and we want to see, it's almost like reversing, trying to find that bicarb, sort of, like how the bicarb's kind of reacting, is how I took it. I don't know if that's 100% how it works. But essentially we're taking our anion gap we just solved and kind of using it more. So we're going to calculate the excessive anion gap, meaning how much more we have than normal. Remember, normal's 12, so we want to see how much more we have, which we're going to do by subtracting the total, which is what we calculated before in Rule 2, minus the normal. Normal is always 12. That's a constant. You're always going to put 12 there. And then later on, we're going to add our bicarbonate that was given to us in the vignette or in the problem or in our lab sheets that we got back from the lab when we were in clinic. So what happens is, up here, you see the 20, the 30, and the 23, right? So if the sum is more than 30, which makes it outside the normal range of bicarbonate, in this situation, I think they're saying the normal range is 23 to 30 instead of 22 to 26. When you're outside the range of 30 on the upper levels, think of it like you have more than 30 bicarb, which means basic, right? So if you have more than 30 bicarb, that means you're way more basic. So that's going to hone you in on a underlying metabolic alkalosis, right? Because you have more bicarb, theoretically. Okay. Now, if you have less bicarb, so less than 23, less than the normal bicarb, is what he said. Well, you have less bicarb, less base. Less base means more acid. More acid is what happens when you have less base. So this is a non-anion gap. That's what AG stands for. Non-anion gap metabolic acidosis. Okay. So these are the processes you're going to be using or getting at in Rule 3. Okay. So here's how we use the formulas. Excess, you're going to calculate the excess anion gap by subtracting total anion gap minus the normal, which is constant 12. Then once you find that, you're going to plug that bad boy right into here. So you'll plug the excess anion gap in, add the bicarbonate you were given at the beginning in the formula. So we're going to scroll up. Oh, we don't have an example. Okay, well, I'll show you in a second. Sorry, that was a little disorientating. So you'll plug that in, bring that bicarb down, add them together, and then you want to evaluate, is it more than 30 or less than 23? I think if it's not either of those, that means that there's no process there. There's no additional process that's happening. is what I was assuming. The notes, I don't know if the notes were very specific on that. That's what I'm pretty sure is how it works. Okay, so again, if it's more than 30, that means bicarb was added or there's more bicarb. And what that means is you have bicarb added to the extracellular space. What I mean by extracellular space or EC space is it means the space outside the cells within the blood vessels. So that means we're adding more to the plasma or blood, right? So we're adding more bicarbonate to the blood, and that's where we're measuring the pH. We're not measuring the pH inside cells or in the interstitium or in the tissues. We're measuring it in the blood. Okay, so more than 30 of bicarb, more than 30 means bicarb was added to the blood essentially. So if it's added to the blood, that means there's more base, so metabolic alkalosis. I'm just kind of re-explaining it again, just so it gets in there. And then for less than 23, bicarb was removed from that extracellular space, removed from the blood and the plasma. So then you have less base, acidosis, just like I just said. And this the way this is going to happen for this 23 one is renal or GI losses, is what he put in his notes. He didn't put any examples for this one, so. Okay, let's do our examples. Sorry, I took so long to get to these. Example 1. What I do is I write them all down here, coordinate them for you. Write them all down here, and then I write, is it high or is it low? And then based off that, I ask, is it basic or is it acidic? Okay, so let's go through these. pH, more than pH of 7.50. Is that high or is that low? Well, that's high, right? That's high. That's more than 7.45. What does a high pH mean? Does it mean acidosis or alkalosis? No, I know I have the answers here, but it means alkalosis, right? It means more basic. Higher pH means more basic. Okay, moving down. CO2 is 29. Well, that's less than our 35 to 45 that I wrote up here, right? Less than that. So that means that it's low. What does a low CO2 mean? Well, I said CO2 was like, you want to think of it as an acid. So low acid means that it's probably more basic. More basic means alkalosis. Okay, last one, bicarbonate, 22. I mean, it's a little low normal, but it's within that normal range, so we're just gonna keep it at normal. Nothing changed, so we don't need to deal with that one right now. Okay, so what is PCO2? Is it respiratory or metabolic? That's the main question you want to ask for this, right? When you're doing these questions with bicarb or CO2, whichever one matches the pH, you want to ask, is it respiratory or is it metabolic? Well, you breathe out CO2, so that means it's probably in the lungs, probably respiratory system. So respiratory equals PCO2, so that's probably going to be one of the components of our process. And then here we saw that the two mimics said alkalosis. So just plug those two things in together. Alkalosis goes here. Respiratory, because it's CO2, goes here. Again, let me know if I'm going too fast or if I'm skipping steps that you're not quite getting. I know this is on a video, so it's kind of hard. Let me know and I can jump into a call. We can talk about it. And I can edit the video to have more context. Okay. Well, is there anything else? Right? Is there anything else based off this? Well, bicarb was bicarb wasn't abnormal. So there really is nothing else to do right now. We could do rule 2 and 3 to make sure, but there's more questions that we can do to show that. Okay. And since there's no other changes, this is most likely an acute process. Right? This means that this is so new onset that the body hasn't realized it's happening and hasn't started compensating for it. If there's no compensation, that means it's an acute process. Okay? If there's only one process going on, it's an acute process. So you put acute process here. And this is mainly going to happen in respiratory. Acute usually happens in respiratory. The reason why is I'll tell you why metabolic's a little different. And by the way, if you see these deltas in any of my notes I write, that just means change. I just write delta. Okay, so here's the rule, right? Here's a nice rule to follow. So pH tells us whether it's acidosis or alkalosis. Ever since I've been doing these, that's exactly how I see this. pH tells me it's either this or it's this. But these other ones from the arterial blood gas, right? The CO2 or the bicarb, these ones tell me which system. They tell me which system they're in, whether it's respiratory or metabolic. And that's how I split it up in my head. pH does this, these do that. Okay? Now, to find out which one you're dealing with, CO2 or bicarb, you want to find the one that mimics the pH. So if the pH says alkalosis, look for the one that also is alkalosis, whether it's bicarb or CO2. So that would be low CO2 or high bicarb. Look for those. Whichever one mimics that pH is going to be your primary process, meaning the main thing going on, probably the first thing that's sort of causing issues, and why the other things are happening, if there are other things. Okay, ones that are the opposite of pH are compensatory, meaning your body's trying to actively change what's going on, so they activate a process to change that. That's a compensatory action. And we'll use the example to show how that works. Okay, so we did have the example before, so now we're going to have this example. Probably going to be more complicated just by order of events. So I have your things down here. What is 7.34? 7.34, is that acidic, or is that high, or is that low? That's low. Okay, does low pH mean acidic or basic? Well, low pH means acidic. Okay, moving on. CO2. CO2 is 60. Is that a high CO2, low CO2, or a normal CO2? That's a really high CO2. 60 is, I don't know what, I haven't been in clinic, so I don't know if that's like super high, but that seems pretty high. So high CO2. A high CO2 we see as acidic because we see CO2 as acid. So when we have high acid, it's acidosis. Okay? Now moving on. Bicarb. Bicarb is 31. Well, bicarb is also high. That's, it's more than 22 to 26. So bicarb is also high. So that is going to be more base. High bicarb means more base. More base equals alkalosis. Wait, huh? Wait, how does this work? How do you have a process of alkalosis and acidosis at the same time? Well, that's what we were just talking about. This is probably a compensatory question. It probably has compensation going on. Okay, so first we want to ask this first question, and this is rule 1. What is the primary? Primary is the one that mimics the pH. Okay, out of these ones, which one mimics? Well, we're just going to say, okay, pH is acidosis, so look at the other acidosis. The other acidosis is CO2. So CO2 is going to tell us what our primary process is. Okay, so pH is acidosis, so that's the second word, acidosis. And then CO2 is respiratory. So respiratory tells us our first word, respiratory. So our primary process is respiratory acidosis. That's the primary process. That is not our answer. Okay, we're not done. That just tells you your primary process. But you had to realize, wait, bicarb's abnormal. There's something else going on here. This is not an acute case. Okay, so no. Look at bicarb, it's abnormal. So we have more to do. Okay, if you have an abnormal, not aligned with pH, meaning it's just the opposite, usually it's opposite, right? It's either you're the same or you're the opposite or you're normal, right? Then it's probably compensatory. If it's not the same as pH, then it's probably, outside of like one situation, compensatory. Okay, this is compensatory or compensating is usually your body trying to, again, correct that issue. So we have a respiratory acidosis because that was our CO2 and our pH. And we also have a metabolic that is trying to compensate. We know it's metabolic trying to compensate because obviously, well, for respiratory it can't be the other one, but we know it's metabolic because this HCO3 is abnormal. HCO3 happens in the kidneys. It happens there because it's metabolized, right? So metabolic process. Bicarb is a metabolic process. That's how it changes. So the overall name that we're gonna put together with rule 1 and another part of rule 1. Oh, should I erase stuff? Another part of rule 1, right? We're gonna make it into one name, which is called chronic respiratory acidosis with metabolic compensation. You say metabolic compensation, right? So you find what your primary is, that goes first. Then you say with this other thing that also was happening to compensate. And the reason why it's chronic is because we initially had a respiratory issue, and then we had a compensating metabolic issue. And in the notes, he said that it takes 3 days to 72 hours for the metabolic compensation to take place. That's not a short amount of time. That's not an acute process. That is a chronic process. So that's why we put chronic there. Now, when it comes to a metabolic process being corrected by a respiratory process, we don't put chronic, right? We don't put chronic mainly because the respiratory compensation happens within minutes. It can be very acute. So the person could have been having the issue maybe 30 minutes ago, and he's already having respiratory compensation. He's already hyperventilating or hypoventilating, one of the two. Okay, now we're going to get into the more complicated stuff. This is going to be rule 2 and 3. Again, drink of water. I'm sorry this is so long. I need to go a little faster. Okay, so this is our example. Here's our information. Take your time to read it if you want to. We've already gone over this in class. So here's our values. So pH. We're going to do our same thing, asking the same questions. pH is 7.5. Is that high or low? It's high. What does high pH mean? High pH means it's more basic, therefore it's alkalosis. Okay, moving on. PCO2 is 20. If PCO2 is 20, that's lower than its normal. So that means it's going to be less acid. Low, less acid. What does less acid mean? It means alkalosis. Okay, good. We already have an idea of what might be going on. Okay, bicarb. Bicarb is 15. Bicarb is 15. Now, 15 is less than its normal. And its normal is 22 to 26. So that's also low. And that means low base, because bicarb is base. Low base. Low base means acidotic, or acid. Okay, so let's ask ourselves, what's respiratory? Oh, sorry. What's primary? Again, how do we find primary? We look for the mimic. Okay, the mimic. Let's go look at it. pH is alkalosis. Go look for another alkalosis. The other alkalosis, oh, look at that. CO2. CO2 is the other alkalosis. So we take the second, so we found the alkalosis in our answer from the pH, because the pH said it was alkalosis. And then we said, okay, which one mimics? CO2 mimics, and CO2 is a respiratory process. So our primary process is respiratory alkalosis. Does that make sense? Well, I guess we have our answer, right? Moving on. Okay, look for A, B, C, D, look for respiratory alkalosis. No, don't do that. You have a lot more to go, and believe me, on these tests, there's going to be a lot more to go. Okay. I said, is job done? Job's not done. I put Kobe there because that when he says that, it always makes me laugh. Okay, let's use rule 2 and 3. So what I want you to remember from rule 2 and 3 is those formulas, right? So rule 2's formula was anion gap equals sodium minus chloride plus bicarb. So cations plus, or cations minus anions. You want to find that gap between them. Now, what was a normal anion gap? It's around 12, right? 12 or lower, typically. And abnormal would be more than 12. So for anion gap, we're looking to see if it's going to be more than 12. So let's plug in our values. These are the values that we have just up above. Just simply plug them in. Plug and play. Oh, keep doing that. Okay, sodium is 145. Chloride is 100. Bicarb is 15. And I'll stay up here if you need to get down the example stuff. Sorry, I was going kind of fast. Okay, and then we do our calculations. Sorry, we do our calculations going down. We get anion gap of 30. Well, anion gap of 30 is definitely more than 12, so we know it's a metabolic acidosis. Right, because that's what we said before. We said the anion gap, if it's more than 30, that means there's more cations, and cations are acidic, so that means it's more of an acidosis. So it's more of a metabolic acidosis if it's more than 12. That's the reasoning behind it. You can just remember that high anion gap is metabolic acidosis. You can just memorize that too. Now, we also said before, I just want to keep this in mind, that an Ag above 12 means it's a primary process, so it's probably the primary thing that happened. Okay, so that kind of hinges in, it's like, oh, maybe the metabolic acidosis happened first, and maybe we should look into the causes of that. Okay, so we're going to keep going. Okay, we keep going, and I want you to remember Rule 3's formulas. Excess anion gap equals total minus normal, and then we'll use that to add bicarb to the excess anion gap and see if it's more than 30 or less than 23. Okay, you remember that whole thing? I'm putting them here so it's a little easier to see. You don't have to go all the way back up. Okay, so we're going to do our calculations. So we said that the total anion gap, and this is the total, by the way, when you calculate it in Rule 2, the total is this one. You're going to bring that down, plug it in. Then you're going to minus it by 12, because 12 is that constant. It's that normal anion gap, right? So you're always going to minus 12. You'll get 18. So now you have your excess anion gap, that's 18. You want to plug that into your next formula up here. Then add bicarb, so 18 plus the bicarb we had in our question, which is 15, gives us 33. I was going to say 23. 33. So now our next question, this is a Rule 3 question. Is it more than 30 or less than 23? Well, pretty clean cut. It's more than 30. And what did we say? If you have more than 30, think of it like bicarb. If we have more than 30 bicarb, is that more basic or more acidic? It's more basic, right? Because bicarb is basic. So it's going to be an alkalosis process. So we're going to have metabolic alkalosis as well. Okay, so that's our answer we got from Rule 3. Okay, so wait. So what is the answer? It's metabolic alkalosis, right? So if you go A, B, C, D, E, you're going to choose the one that just says metabolic acidosis, or alkalosis, right? No. Remember, when you're doing these on your paper in the test, please go, like, as soon as you get done with, like, one of the rules or get done with solving something, circle it. Circle it on your paper so that you say, oh, yeah, don't forget to come back and put this back in as one of my answer choices. Okay? So our total answer choice is respiratory alkalosis, metabolic acidosis, and metabolic alkalosis all at the same time. That's going to be a question. He's going to make it so there's going to be an answer with all three. Please, please, please don't just put one if you calculated all three. You did all that work. Don't just, don't waste your time. Don't do all that work and just get it wrong. Okay, again, I said this before, but the max amount of abnormalities or processes you can have at the same time are 3, because again, you can have 2 metabolics and 1 respiratory. You cannot have 2 respiratory because respiratories deal with hypo and hyperventilation to compensate, and you can't have hypo and hyperventilation at the same time. Doesn't work. Okay, so 3 abnormalities at the same time. This is the most you can have. Will most questions be like this? Probably not. Most questions will probably like 1 or 2. But 3 is an option, and I wouldn't doubt him putting a 3 on there. It's a good question. And I put some more examples here in case I want to like show people how to do stuff, and you can like do your own work on these. I posted in the Discord. Do your own work on these. Erase it if you want to retest yourself. Okay, I hope this helped. You guys got this. We're almost done with this quarter. You guys are doing great. Let me know if there's any problems, or if you guys want me to do these examples on my board, and I can post another video of me doing it actually on my board. You have to deal with my ugly mug, but that's fine. I'll do it for you guys if you guys need it. I'll see you guys on Monday, and good luck.